Hello and welcome to our latest webinar on research data management. We're going to be discussing the process of handling movisens datasets with ease, with the overlying premise that quality data leads to quality outcomes. We'll be talking a little bit about us to begin with, and then giving some overview and background of research data management. Then we'll dive more into the specifications of movisens datasets, looking at our different software and processes that we use to work with the movisens data. And then we'll provide some broad recommendations on how to go about working with our data to maximize your results. And finally, we'll conclude with a question and answer. If at any time throughout the webinar you have any questions you'd like to ask, please write them into the group chat where some of the other research consultants are standing by and they can answer your questions as we go. Now, a little bit about movisens. Movisens is actually a spin-off from the Karlsruhe Institute of Technology, where there was an interdisciplinary research group studying the relationship between stress, physical, and mental performance. And part of that charter was to develop better tools, techniques, and resources to actually study that relationship. We were established in 2009, and we're still based in Karlsruhe, and we have 17 employees now. We have an international customer base, including distributors in multiple territories now to help serve our customers' needs. We are the only company that offers research-grade solutions for both gathering objective data, so physical activity, autonomic state, sleep, cognitive function, and also subjective data through experience sampling or ecological momentary assessment, mobile sensing, context, and geolocation. We encourage a framework of interactive assessment, so where we're using solutions for multimodal ambulatory research and combining different elements. So we get the objective data and then we inform that more with our subjective data. And we can synchronize the two data sets, which is something we'll be delving into a little bit later on in the webinar. And also interactive assessment. We've done plenty of webinars on the ability of physiological data to trigger questionnaires on subjective data so that you can gain insights into the actual participants' behavior, what's actually driving that behavior, actually informing that physiological state. Ambulatory assessment has a lot of advantages. Firstly, real-time assessment gives us a higher precision in our subjective data, and assessment in everyday life gives us ecological sort of validity. It's generalizable. We can then repeat assessments more conveniently to observe dynamic changes, and our favorite topics here, multimodal assessment, so we can look at things like the psychology, the physiology, the behavior, and the context, and then interactive assessment, where we're utilizing queries based on physiology, behavior, and context to build a broader picture, so coloring in the picture of what's actually happening in the participant's life. Now let's get into our main topic. So we'll talk a little bit about the background of research data management and also what it means to us. Now, research data is anything that really is generated during a research process or as part of the actual results. Handling research data in a sustainable and open way promotes transparency. It allows us to actually reproduce our results, and also we can reuse the different data sets to answer other questions. And this plays a really good role in safeguarding good academic practice. Responsible research data management is really beneficial to both researchers and potential subsequent users, making a significant contribution to the acquisition and dissemination of research insights. With most grant applications now, the funding bodies want to see that there is a data management plan within the grant application. Publishers also like to see that there is some sort of data management plan for long-term sustainability and verification of results. Data sharing provides benefits to individual researchers and institutions. Data sharing requires raw data sets, and it's fast becoming a new paradigm in research across multiple disciplines, which requires open raw data formats to ensure research continuity. Now, why is research data management important? Appropriate handling of research data is an important mark of quality in your academic work. The guidelines issued by funding organisations and rules governing good academic practice enforce a systematic and sustainable handling of research data. Good quality data enables good quality research. So a quality capture gives you the possibility of obtaining quality results. Data creation is time consuming and expensive, so having an excellent research data management plan will make your research more cost effective. Data is a core element of research. It is essential. We have to obtain the raw data to actually make our research possible. It also complements published findings. It allows us to then use those data sets to reinforce existing work or to inspire future work. Compliance is essential. So we need compliance with different data protection requirements, which are incredibly strict over here in the EU and also in different lands around the world. Protection from loss, destruction, or misuse. So some sort of security. So there are 4 FAIR principles which are requirements when storing data. It needs to be findable, it needs to be accessible, interoperable. So it has to be available and usable on multiple different systems, and reusable. Only by storing research data in a structured way with metadata can it be retrieved and used by others. Now let's look at the life cycle of research data. Here we have a range of steps with different activities, beginning obviously in the planning stage. Our data merger software actually provides recommendations on how data can be structured for optimal use later on. So we have a different way of looking at the management of data in different forms. We planned the data management, so we're looking at what formats we have, what storage is required as well, and the actual process of how we work with the data once we have it. Then on to data collection. Collecting meaningful raw sensor data that can be processed further means that it is then transparent. There is no pre-processing occurring. This is essential if you want your data to be sustainable long term. Quality, high quality capture also enables it to be sustainable and reusable. A quality measurement endures. Security. So we need to securely collect and store the different subjective experience sampling data and the physiological data. So it's essential that the tools that we use have a strong focus on security and compliance with different regulations throughout the different countries. Moving on to documentation. We have the storage process. Data needs to be stored and made available in data repositories. The different criteria for data selection for retention and access rights needs to be clarified in our process. We provide a very high transparency when analyzing the raw data, and it's essential that whatever tools you're using also have a transparent process and transparent algorithms that are available for examination. So obviously the preparation and evaluation of the data is the core of the scientific activity. So we need to go in and actually look at our data sets, have a process that we understand how we're going to prepare them for analysis, actually go through the evaluation process, so actually analyzing them. And the clear thing there is obviously a requirement for some sort of transparency that then the results are replicable later on. And then the interpretation of the results, which is the key part for the researcher, actually giving the data a voice and actually providing that voice in the next phase, which is the publication. What is the process, and sharing the results throughout the world. And then obviously after the publication, the next stage is actually the storage of the data, making sure that that data remains available for future reference, for later use, and that it's in sustainable format. So the open source or raw data format is essential, because then as technology develops and new possibilities emerge, the raw data will say sustainable. Future research. Obviously, future use becomes a big issue. We want to be able to maximize the use of our data. So movisens hosts its movisens Access data with no limit towards size or time, which ensures the permanent availability and traceability of the data, enables its future use, and gives us additional opportunities to run checks and data enrichment as opportunities come. So in the publicly funded research projects, the research data should also be publicly available. Research results from industry-funded projects sometimes will remain proprietary of the respective companies. When it comes to future use, we need to take into effect the ownership rights and observe what the actual process is within our organization. But it's also really important to be able to undertake research reviews, so to be able to access that data again to make sure that everything was done properly within the study. Specifications of movisens data. Now at movisens, we generally provide two data sources. We have data that comes from our sensors, so objective data that's actually tracking a physiological device, so it's capturing actual signals and hard numbers. So the raw data source is recorded, and we store it in the free and open Unisens data format. So this is a international open source format. Then we have the movisens Access data, which deals with the subjective data, so things that we're asking the participants, we're asking them questionnaires, we're getting their opinions, their feelings on things. And that's extracted from the movisens Access web platform, and you can download those results either in a XLSX or CSV format. Now, when it comes to the sensor data that we capture, for two reasons, it's incredibly important that we capture raw sensor data so that it's something that's sustainable long term, and it can be actually imported into a range of different platforms and software applications to work within. Our own algorithms also utilize raw sensor data, so our data analysis software relies on a raw data format. And our sensor ranges, capture the following raw data signals. So depending on which sensor you purchase, you'll get the option of capturing stuff like electrocardiogram, electrodermal activity, ambient light. But in all cases, you get acceleration in 3 dimensions, angular rate in 3 dimensions, atmospheric air pressure, and temperature. Now, among some of the many advantages of capturing a raw data source, we have openness. So it's really important that things are transparent, that data isn't bound to any proprietary algorithms. So some other research-grade equipment and most consumer-grade equipment outputs calculated values, and it's a little bit more of a black box process. So there's no transparency and often quite a lot of pre-processing. So one of the key elements of raw data is that there's no pre-processing that's performed or aggregation of the data. You're getting the signal as it's captured, which then opens us up to the option of future use. So further analysis options can be explored as new algorithms are developed. So we can actually reanalyze the data if better algorithms become available without any restriction that could have been applied by an aggregation step. 3, we can monitor the complete data stream. So this helps make results reproducible and sustainable. So the complete series of analysis steps from raw data to final output, you actually have as an overview. You know what you have done to this data. And now over to the subjective side of the data. So data that we're gathering from the participant by asking them actual questions, and sometimes it's other information on their context and behavior. But these results are uploaded from a smartphone when either a mobile data connection is present or Wi-Fi connection. It's always encrypted at rest on the smartphone, so even if the device gets lost, no one can actually decrypt the data and actually discover the answers that the participant has been submitting during the study. It's GDPR DSGVO compliant, so the data is stored encrypted on our servers and stored with pseudonyms to protect the participants. And it's only decrypted as soon as it's entering the secure web console and you're downloading those results. Now we're going to talk a little bit about the software that we use, and in particular we're going to focus on the software related to the objective side, so the physiological sensors and the data that they're capturing and how we go about processing that. So we have 3 core elements of software that are utilized in our data management process here. So we have the sensor manager. The sensor manager software generally is involved in preparing and configuring the measurement, so actually getting the sensor ready to measure for whatever duration on whatever participant and capture all of those raw signals that will then be used later. And it's then also utilized to actually extract that data and store it on your local system. So it doesn't go through a cloud at all. It's a direct USB connection between a little cradle that the sensor connects to and your machine. We have the Unisens Viewer, which we'll be touching on in a little while now, and it's used to display and edit the data, and you can also view the calculated secondary parameters on the Unisens Viewer. The DataAnalyzer. Obviously, the name says it all. It actually will perform the calculation of the secondary parameters at whatever epoch you want. So an output interval from 1 second all the way through to a day's worth of seconds if you just want a daily report. And it will also create reports and tables, which are quite convenient for participants, especially giving them some sort of feedback as a thank you for participating in your study. And once the output comes from the DataAnalyzer, further processing is possible with SPSS, SAS, R, Excel, and so on. Now, onto the sensor manager. So this is where we're actually going to start our data gathering process. After all of our documentation, we're actually going to go in here, utilize this to actually start a measurement. So we have, in this case, we have a Move4 sensor that's been connected, serial number, firmware revision, firmware ID, the current battery level, and it also will tell you if there's actually a current measurement that's been stored on the device so that you can then save the measurement data, or if you've already saved it, you can start recording and it will give you the option to delete it. Over here we have all the different measurement parameters that we're going to be capturing, including the sampling frequencies, so that you can see what level of signal quality you should be striving for. Now, when it comes to the preparation, we need to configure the measurement. We set the measurement duration or the start condition. There are different options for this, depending on the sensor that you're using. With all sensors, you always have the option to start the measurement immediately or to delay start it at a specific time. So obviously that time has to be in the future. Please be aware that it is gaining its clock from your PC. So whatever computer you have it connected to is the one that's providing the sensor its current time and date. With our ECG sensor, there is an option to start the measurement when the sensor is put on. So obviously that is blanked out here because it's only a Move4, but if you have an ECG, you have that option to actually just click here to start the measurement when it's put on, and then once the measurement is commenced, so once the sensor detects an ECG signal, it will then continue the measurement until it either runs out of space or it runs out of, the duration expires. Now you had some options here as far as your participant. You can either use an identification number and you can put age or birthday, weight, height, gender, and sensor location. You can either enter that now or you can enter that when you're actually extracting the data. When you plan to actually send the sensor back out with a participant multiple times, it's a good option to actually store it on the sensor, and then you can load it directly from the sensor by clicking on that button, and it will then pull the data that it already has and use that in its extraction. So after all that is done, it starts the recording and you can remove the sensor from the USB port. And then when it comes to storing the data, we're going to use the exact same software. So we'll start the sensor manager, connect the sensor to the PC with a USB cable, and then we're going to store the data. So we have to select a folder, specify the folder name, so the ID and measurement time in folder name, which we can obviously adapt and change by hitting the 3 dots here. We can select a different base folder. And then there's the data folder for this particular measurement to go into. And what we can easily do is get the timestamp that the measurement was started by just clicking on this button, and then it will automatically populate the timestamp. And then we recommend adding other information in here as well. So obviously, critically, we have to add the participant identification, like the proband ID, age or their birthday, weight, height, gender, sensor location, and any comments, so any issues that came up with them wearing the sensor or medications or other information that could have an influence over their physiological state whilst wearing the sensor. And once all this is prepared, you then click on Save Data. When storing the data, it's important to get into good practices here and specify the file name with clear identification and measurement time in the file name and in the folder names. So the data should be stored in the following structure. So even if we look here as an excellent example of a study that was done, we have the overarching measurement data folder here, and then we have participant Air 001 at time point 1. So that time point will actually be a time point potentially in when you're actually going through the study and just utilizing the sensor manager's timestamp feature. And here we have Air 001 time point 1 EDA, and then we have Air 001 time point 1 ECG. So they were capturing two measurements on this participant at the same time. And then we have the same here for Air 001 time 2. So it's the same participant at a different point in time. And once again, measurements of EDA and ECG. And then we move along here and we have a separate participant, a new participant, Air 002 at time point 1 EDA ECG, and then at time point 2 EDA ECG, and so on. Once you actually extract your data from the sensor, you need to check for some things. You should not delete it straight away. It gives you the option to do it if you're feeling supremely confident, sure, but it never hurts to check these things. So we want to check for a couple of things. We want to check for completeness. If we were after a 5-minute measurement or a 5-hour measurement or a 5-week measurement, we need to see that it recorded for that time. We need to check the whole signal. And then we need to see the quality of the data that we captured. Are all the signals in the right area? Are they in the right range that makes it physiologically normal? And then the best way to do this is to view the data with the Unisens Viewer. So in this case, we had an hour-long measurement. And so we can clearly see that the signal was captured for an hour. We've got a time point there that we can reference at the top. So the actual duration of the measurement was fulfilled. And there's clearly some actual signals going on. And they're within realistic thresholds. So we can actually go along, and we'll do this in a moment with an actual proper measurement that I'll set going in a moment. And we can see that everything was physiologically normal. Look at things like the pressure. We can see a decrease in barometric air pressure and then an increase. And that's symbolic of going up a hill and down a hill, or up some sort of slope and down some sort of slope. And different intensities here as far as the acceleration signal. So we always go into the folder, and we can actually see in our data folder that the bin files, they contain the raw data of the measurement. The Unisens XML actually describes the measurement, and it can be edited with like a text editor or like WordPad or even Notepad if you're really old school. The data can also be saved in .csv format, which some people prefer, but please be aware that saving in the .csv format means it cannot be evaluated with our DataAnalyzer software anymore. We require the raw measurement data. Once we're happy with our measurement within the Unisens Viewer, we can go straight to data analysis or analyze data, and it will take any edits that we've done, it will take this final measurement and then open it within our DataAnalyzer software. Please be aware, any edits you do within the Unisens Viewer are writing it to the file. This is why it's very important to work from copies, to keep an original copy or an original and then work from copies when you're doing any editing or cleaning of your data in case you make a mistake. Then you can always go back, copy your original file again and get to work pre-processing the data, depending on if you need to divide it up or slice out different things or mark different artifacts. Once we open the data analyzer, we select a measurement, so the Unisens XML of the desired measurement folder. Then we can go and set the output parameters that we're after, that we're interested in. and we can take all these different elements here, enter or check the personal parameters. So if there weren't any personal parameters that were entered during the actual collection phase, this is another opportunity for us to measure them. And then we can select whatever our output parameter is that we want. So whatever interval in seconds. In this case, it's been chosen at 60. Then we save the results in a new folder. So the new result folder will be the name of the measurement, so the existing folder, then the word result, and then the time that the analysis was taking place. And then further processing. So DataAnalyzer extracts the secondary parameters into CSV format, which then allows you to take that data further and run it into a more dedicated statistical analysis package, either Excel or SPSS. We have another mode, which is the study mode, which actually allows us to do a batch analysis. We can actually then take every single measurement within a folder and run an analysis on it and get all the calculations. So if you have a really large study that's being run over a long period and you have a whole range of measurements, you can just set that going and then go and have a very long lunch and come back and look at your results. And to put this in some more concrete terms, and not to completely slay you all with Jana's PowerPoints, I'm now going to just do a quick demonstration. So we're going to open the sensor manager. It's going to look for a sensor, and I'll connect one now to my PC, and it will search to find out what sensor is actually there. In case there's a measurement already running, it will warn us that a measurement's actually currently in progress, and do we want to stop that measurement? Or do we want to just continue the measurement going? And now we go into all this information where we see we've got a move for its serial number, the firmware, also the signals that we're capturing here. There's no measurement currently on the actual sensor, so we can go directly to starting recording. The battery is above 10%, so it's going to let us start a recording. And then we can just say, okay, we want to measure for days, weeks, or hours. Let's go with 5 minutes. That's all we're going to do. And then we're going to start this. Obviously, you can see the time I'm recording this right now. And we're going to start it in 5 minutes time from now. Now I have an option to disable Bluetooth during measurement. I can either check that. If I want to do a very long measurement, sometimes the Bluetooth will take some extra battery. So if you're sending it out to the field and you don't want the participant to have to interact with it, sometimes you could actually just set it going to a 7-day measurement, disable the Bluetooth, and then you'll get the absolute most out of your battery. But in this case, it's not really important for me. Now I can load the participant info from the sensor, and this should give me the last measurement that was performed. So it was participant 1, 32, 75 kilos, 175 centimeters, male, and it was being worn on the right side hip. And then we can start, and it will then tell us to actually remove the actual sensor from the cradle and get ready to do the measurement. And so using our computer editing features of the future from the past, I've just done a 5-minute measurement, and I'm going to now connect the sensor back on to the actual PC onto the docking station. So it's going to read out the sensor status, and we'll then see what the data says. Shows us we have a 5-minute duration measurement. We can then save our measurement data, and we can go through and check to make sure that everything's correct. Up pops our little prompt to save the data from the sensor, and we can look at what the base folder is, adjust that if we want. Then we can generate that timestamp that we talked about. So in this case, we have the participant ID as participant 1. We have our timestamp here. Any comments, any other remarks. And obviously we can save the data as CSV, but we really don't recommend that you do that. We recommend saving it in the Unisens format. It is then a raw data format that is going to be durable and will last, and will, most importantly, function in our analysis software. And also, it's then it's a smaller format as well, so it won't consume as much storage space. And you can then still import it into things like MATLAB, R, Python, Ruby. I'm pretty sure there are import libraries for these things. So the data has been saved. Now, because this is just purely for the video, I'm now going to just delete the data from the sensor, and then we'll move on to the next stage, which is to show the data. And what we can see straight away is that I was looking to see on the sensor when the measurement was starting, to see when the blinking light commenced. And once I saw that, I then started walking in motion. I'll just group it. And all these different little elements, you can see there's a change in the pressure here. That's actually me walking down to the cellar, walking around down inside the cellar a little bit, then also heading back out. And then we continue along, just walking, taking it easy. And then you can see that the acceleration and the gyroscope signals stop. And there's still a small amount of motion within them. And that's basically me lying prone and then rolling over, lying, getting up again, coming and sitting down the chair. And here's a cool thing you can kind of see with the angular momentum, because I was swinging around on the office chair, waiting for the measurement to stop. So obviously nothing critical about this, but what I could do is I could say, actually, you know, this bit that's swinging around the office chair, I don't need to analyze that. So I can just come here, select that, go to our edit, trim the start or the end, and then this warning is very important. I know it's in German. Trust me, we're working on that. It's telling you that all of this data that you've selected will be deleted and you cannot undo this function. So this is why it's important to work from a copy of the data. Obviously, in this case, for this demonstration, I'm not. Normally, the process would be you would store it, then you would copy it into an area where you plan to do work with the data, and you work from those copies. And it's because it's more than 10% of the data, it's going to warn me again saying, are you really sure? And because I am, I'm clicking there. Then I'm going to analyze the file. This will then open this edited version straight in to my DataAnalyzer software. And then I can select the parameters that I want to actually calculate. I mean, I don't really need all of them, but for the sake of interest. And then we can select our output interval. You can enter anything. I could have a 1 second output interval if I wanted really large data. But when we're talking about measuring things like movement and activity, 30 seconds, 60 seconds are all very good values to be looking at. And I'll just run a quick analysis on that. And at the end, we get this little pop-up window, which then tells us that the features were calculated and gives us some options on what we can do. So we either open the destination folder to see what's been calculated, or we can just show the results in the Unisens Viewer again, which is what I'm going to do. And I'm going to see that everything worked out as I expected it to. So I'll just select all quickly, and then we can look and see all the different signals that we're interested in. So, and what the interpretation is. So temperature, we can just kill some of these at the moment. Step count shows us that I was walking, you know, the amount of steps that I was walking at that time. Markers, in case you set any markers, all the different elements of movement, acceleration. Body position is probably interesting because, yeah, you can see here I was laying on my stomach, and then I swapped to laying on my back, and you can then sort of determine that by looking at the body position, signal entry, and the interpretations on what it actually means. So the number 1 is lying supine, and then 3 is lying prone. So but obviously, we're not going to be doing much in the way of analysis with the viewer. The viewer is just there as a tool for us to see how the measurement has taken place, to make sure all the signals were captured, and to make sure that everything makes intuitive sense to us. So the more of these measurements that you see, the more you'll come to understand, okay, this is correct, or hang on, I can tell there that the participant wasn't wearing the sensor. And then you can actually reliably talk to the participant and say, yes, we can detect when the sensor is being worn, when it's not being worn. for issues of compliance, especially if you're reimbursing them or compensating them for their time. So here's the measurement that was just performed. We have the elements that were recorded, and then over here we have the results folder, which has all of our different CSVs, all of those calculated values. We can either go through individually into the CSV, or we can go directly to a results XLSX file, which will actually then bring all of the information in from the different CSVs. So we have day 0, obviously, the time in relative seconds, so the actual duration of the measurement, the actual real absolute time, and the different activity classes that are occurring. And you can see the different parameters and what they mean. So activity class here, number 7 is walking. And we can go back in here and look and see in these epochs, walking was what was happening. And then we have activity class 1 and 2, where we can just see that parameter was lying 1 and sitting, standing is 2. And all of these different elements we can then look at and see. So you can see in altitude, in real terms, yes, I went down to the cellar and then I came back up. Body position, the changes at the different epochs for when I'm laying on, on my stomach and on my back. And in real terms, this is the information that you would then take forward into other statistical analysis parcels or software packages. Now, just jumping back into Jana's beautiful PowerPoint presentation, and I hope it's clear how daunting it can be when you're doing a large study just to actually keep track of the data and make sure that you have access to all the different data points that you need. This is where having a really clear folder structure is important. Having clear offsite backups as well makes a big difference in long-term sustainability, so that you can really get the most out of the data, because once you've gathered that data, it can really drive a whole stack of research projects. So especially when you want to do some sort of batch analysis, having a clear folder structure makes it a lot easier. Then you can analyze all of the different measurements within the master folder, and then you'll get all your analysis results in that zone as well. And that's when you can really then move on to the next thing, where you're actually looking at combining data from different sources and potentially from either different sensors or from completely independent sources such as experience sampling. And that's where we talk about our data merger. So obviously we have our objective data from the sensors and the subjective data from movisens Success, and the data merger is the software that merges and synchronizes the data from different sources for further statistical analysis. Now, it supports data structures from studies with multiple centers, measurement times, groups, and measurement parts, and handles equidistant and non-equidistant data series. So what happens at the end is you will get an output which generates a table with the equidistant data. You can specify the output interval. Movisens Success tends to track everything in 60-second epochs, and so obviously it works incredibly smoothly when your sensor data is also analyzed at 60-second output interval epochs. However, it's not essential. We can still merge these data sets and actually have one complete table of actual results at the end per participant. So it's real massive advantage. Okay, 2 brilliant advantages for this. One, it's free, and so I'd recommend grabbing it from our website before we change our mind on that one. But it just allows you to take data from all of the different movisens sensors, the classical movisens Success data, geolocation data from the movisens geocoder, mobile sensing data from movisens Success, so things like other locational data or other context values that the movisens Success platform can analyze and gather in the background of running a study, and also custom time series data from other sources that have a compatible date and time format. And then you'll get one fantastic results file, and that data file can be used for further statistical analysis, SPSS, R, etc. So, further recommendations. Good study planning. Obviously, we've made a big deal out of that at the moment. So making sure that we're actually planning out what we're doing, what we're striving to do, what are the questions we want to answer from this, gathering this data, and are there any peripheral advantages for gathering more data so that we can actually maybe examine further questions later on down the line. So obviously it's important to be open and this is part of that in this community. So exchanging with other users and visiting workshops and webinars. We're always available to help you guys. Backups, super, super, super important that you are working from copies of your data and factoring in that having backups is a key component of storage and a data management plan. Pilot study. Preliminary studies are always essential. Always carry out a complete preliminary study, including the analysis. So test your study for the complete planned duration. So for a 2-week main study, do a 2-week preliminary study. Don't think that you can skip this phase. Don't think that you can shorten it down. There is always something that can go wrong if you don't test the whole procedure. Compliance. So sometimes we actually also have to be a little bit realistic, unfortunately. Something I personally struggle with. I like to shoot big, but sometimes it's worth answering one research question really well and not trying to answer 10. But maybe other times you can then look at multiple ways that you'll be able to utilize that data in the future that may not actually have to complicate things. But it's important that we have the right motivation and sometimes using things like gamification, not exaggerating what we're trying to achieve, being in close contact with our participants so that they understand what's required of them. And complexity, keep it as simple as possible. Delegate. Obviously, you're building teams of people that you're working with that will be involved in publishing this paper. So it's important to make sure that you utilize each other's skills as effectively as possible. Now, if this all sounds too daunting, we're also happy to take care of some of this stuff for you. So we do consulting work on study design, implementing studies, data storage, data management processes. We can help you guys put together your grant application and help make sure that it's going to tick the boxes for the different funding agencies for the things that they're looking for. And we can also run an analysis for you. We can actually go through your data sets, extract the meaningful data, run the analysis, and then give it back to you just so that you are then freed of that responsibility and can focus on what you're really good at, which is actually interpreting it, taking that data and turning it into information and then communicating it with the general public and communicating it with other scientists in journals. Now for the closing remarks. As I've already said, we support scientists in all aspects of data management so that they can fully concentrate on their research content. So when it comes to data security, we've already taken care of everything for you. All data protection requirements are met during data storage. Want to outsource your data processing? We will gladly take it over for you. I say gladly because I'm not the one that actually has to do the work, but please get in touch to learn more about this service. All of the movisens Access data is hosted in Germany, so that means we're really meeting some incredibly stringent data protection requirements, and that happens at all stages through our working with the data. And the sensor data is always stored on the actual sensor itself and then on your own system. So we're making sure that you guys have direct access and you can keep it secure as well. And obviously, if we're actually interacting and working with your team, there are specific processes that we put in place to make sure that data security remains, that we're compliant with all the different regulations and rules to make sure we're protecting not only you, but your participants' data and their privacy, and also your research reputation. And if you want to get in touch, and we really welcome your calls and your emails, this is our research consultant team with myself, Darren McLennan, at the top there, Dr. Stefan Hai, Jana Schlicksup, and Lisa Scheurer. There's our phone numbers if you want to reach out and have a quick call with us. Or if you're a bit more shy, you can just write us an email via info@movisens.com. And now I hope that you've all been frantically typing away questions during the process of the webinar, and we're going to cross back live now, and I will do my absolute best to read them and answer them for you. All right, thank you.